Hello, my name is Simon Coggins. I'm the Director of Learning Technology at Totara, and today I'm going to be doing a developer screencast of the new external API and HR services that's been developed for Totara 17. So the plan for today is I'm going to give you a little bit of background on the project that we've been working on to build the new external API, what it's about. I'm not going to go into a lot of detail there, as there's going to be other resources available for that. But then we'll launch into building a demo basically using the new external API. And the plan is to basically walk through all the steps that a developer would take in using the API to integrate with an external system. And the project we're going to build is a standalone tool that will allow me to sync user data between two Totara sites. And the reason I've chosen that is it allows us to make use of the new HR services, and we can see requests for data from those sites, but also mutations or updates to those sites to create the sync. So it'll let us see all the different aspects of the new API. We'll cover making requests and authentication. So we use OAuth 2 for authentication of the new API. So we'll go through that. How to make requests. We'll write some queries to get data from the sites. Then we'll work on the sync logic to allow us to work out which users need to be updated on the destination site. And then we'll write some mutations, which is the GraphQL terminology for sort of write requests to update the target site to match the source site. So just going into the background of this project a little bit more. So Totara's always had an API, but it was based on the old web services from Moodle. And there's a few issues with web services in Moodle. Firstly, that we never really built any services for it for Totara. So it's always been possible to query for courses, but not programs or certifications because they're Totara features. Or you could, create users, but you couldn't create job assignments because that was added by Totara. So the goal of this API is to really provide a comprehensive API that covers all the features that Totara provides. The second aspect is that the architecture on which it was built is a little bit sort of old-fashioned. It doesn't really meet modern standards, which can lead to some issues when it comes to kind of security reviews of Totara, with things like long-lived tokens rather than having refreshable tokens. And also the sort of extensibility aspect. It's a bit hard to take an existing service and extend it to do a little bit more. You have to kind of make a whole new copy. So there was a few reasons that we wanted to improve on that. As I think I mentioned, the new external API is based on GraphQL, and GraphQL was a technology that we introduced into Totara in version 13 when we moved to a sort of API first model for Totara development. And our original use of the API, the GraphQL API, was for our own internal AJAX or JavaScript requests. So it's essentially an internal API used by the JavaScript framework to query the backend server. And what we're doing differently, or what we've done here, is to add a sort of a new version of that API that's based on the same technology, but has its own proper authentication mechanism and is designed for external access. So that's what we're going to be going through today. But so GraphQL is the technology that we chose previously, and we've chosen to build on that for this API. Okay, well, without further ado, let's make a start. So just talking about the plan of what we're going to do. So as I mentioned, we're going to build this standalone example. We're going to try and sync user data between two real live Totara sites. And we're going to build this as a kind of standalone independent system. We're not going to make use of the Totara framework for it. I'm choosing to do that because I just want to remove those dependencies. It might be that you're integrating from an external system into Totara and you want to use the API, in which case you wouldn't be writing in Totara code. So I'm just going to write in kind of pretty plain old PHP. I am going to bring in one dependency. I'm going to use a HTTP client from Symfony. It just provides some useful abstractions around making GET and POST requests. So I'm going to bring that in using Composer. So I'm going to create a composer project for this, but you could do without that. You could just do kind of raw curl requests if you wanted to. If you are integrating a Totara site, we did add a HTTP client library in, I think, version 13. Um, Maybe it was one of the slightly later ones, maybe it was 15, but there is now an HTTP client built into Totara you can use to make requests to other APIs. And then I'm going to try and build some kind of basic abstractions for working with our API. So the idea here is that this is something like we will share the output of this example, and some of the stuff that's in here might actually be useful for you to get started if you want to be making requests to the API. So we'll be dealing with OAuth requests, authentication, and some basic handling of the responses from the Totara APIs. And then, yeah, as I said, what I'll do is as I work through the examples, I'll commit the code into a Git repository, and then we'll upload it to GitHub. And so as a companion to this screencast will be the code that was built during it. You can use that just to see what we were doing in more detail, but also as a kind of starting point for your own code. It's not going to be production ready. I haven't thoroughly tested what I'm going to do here, but this will give you an idea of how you can build things. So yeah, let's get going. All right, so the starting point is just setting up the project. So I've got an empty project file here. I'm using PHP Storm as my IDE, but you can use any IDE. And I've just got a folder here called API demo. And I've just put a git ignore file in here with a few config files that I'm going to use. And I've set up a GraphQL config, which will allow me to use the built-in PHP Storm GraphQL client later. So I'm just going to start a composer project so that I can bring in that HTTP client dependency. Cool, so we should be up and running there. I'm also going to create a Git repository here. And as I progress, I'm gonna tag some of these commits with some tags so that you can jump to any point where you want to see where things are. So I'll just tag this with so let's just call it step 1. So that's available if you need it. So the next step is I'm just going to create some classes that we're going to use and check autoloading's working okay, and I'll bring in that dependency that we wanted. So let's make a start with that. Excellent. And then the other thing that I was going to do was just create some classes here. So what I'll do is create in my source directory. So just thinking about how we want to structure this, I'm going to try and provide some classes that might actually be useful to you. So I think the first class we're going to create is essentially like an OAuth client library for Totara. So we'll pass in the client that we're going to be using this for, and we'll pass in some other fields as well here. The site URL that we're going to be accessing, and the client ID and secret. So the client ID and secret are OAuth 2 concepts. We're going to be using the what's called the client credentials grant, which is essentially a sort of server-to-server connection using OAuth 2. Also known as two-legged OAuth. So we're going to be making requests to a site with a client ID and secret, using those to get an access token, and then using the access token to make requests. Okay. Now we're going to be using this from another class that we'll create as well at the same time. And the purpose of the other class is to actually kind of make the request themselves. So this is now going to be kind of specific to the problem that we're trying to solve, which is this syncing. So I'm going to call this a sync request class. So we'll just create that too. And then I'm going to do one more class, which is the sort of most specific of all, which is just a class for handling the actual execution of the sync. So we'll have the logic around how the sync works itself, and it'll make use of these other classes. So we'll call that one sync. And then finally, I'm just going to create one more file, which is just a file to run this sync. So just do a PHP file here. So all being well, we should be able to just do from the command line here, run that demo, API run. There we go. So we've got running going. So yep, we've just got a script that runs, loads a class, auto loads, and runs the run command, and we've got our shell ready to go. So let's have a think about what we want inside our Totara OAuth2 client class. The first thing we're going to want to do is to be able to make requests. So we're going to need to be able to get a token from our site. Let's have a look at writing a method that does this. So we'll call it get new token, and we'll be making a request and receiving a response. We're going to be using our client, which just as a reminder is the HTTP client library. Now we need to pass in the client ID and secret in the request, and just the format that is used by this is that we can pass in a body object, which will do URL encoded format, and then we can just pass in an array of key value pairs. So we're going to be using the client credentials grant type, as I mentioned before, and we need our client ID and client secret. Now we need to handle this response. So first we need to know whether the request was successful or not. So let's just check the status code. And then we need to actually extract the access token out of this response, assuming it's successful, or at least check to see if it was successful. So we can get the content of the response, which is JSON. All right, now there are certain error situations that we can get out of our response and handle in a slightly more graceful way. So let's look at doing that. So and then I'm just going to store this access token in the session so if it's successful. So the reason for this is we can reuse access tokens. They don't expire immediately. So it just saves us from having to remake this request over and over again. The session's just a convenient place for me to store it. But yeah, so that gives me, in theory, a way of requesting an access token. And then I'm just going to do another method just to allow me to get that token from the session after it's been requested. Okay, so I think that's a good start, and we can probably test out this aspect of the functionality. So we'll go back to our sync task and just add some extra code in here. So what are we going to do? Well, the first thing is we need to generate an instance of our Totara OAuth client, and for that we need a client ID and secret. So I think what I'm going to do there is put some of this stuff in a config file, just so that it's out the way. My client ID and secret, and I can reuse it. Let's make a constructor for this. And that's just going to define a few properties that we can make use of without needing to put in here. We're going to make an instance of our client that we want, and we're going to pass that in with some of these other details. So we're going to make our source client. So this is now specifying that we want a new instance of the Totara auth client, and we need to pass in our HTTP client. We need to pass in our source site URL, which will be a variable that comes from that config file, and our source client URL, and our source client secret. So I've got my instance, and then within here I should be able to call that instance. So I can do source client, and I can call that get new token method. And then we'll just try echoing the token itself if that was successful. Get token. So yeah, so this is going to attempt to make a real request to get a token, access token from a site. So I haven't defined that config file yet with these variables. I'll go do that now offline and come back when it's up and running. So I've defined that config.php file now, which means these variables should be loaded okay. So we're going to just give that a go and see what happens. So I'll go back to my console and I'll just try running. And after fixing a typo, that seems to work fine. So yeah, that's what you'd expect from a token, is something looking like that. So yeah, we've managed to make authenticated, or we've managed to authenticate against the API to get a token. So that's the first step. Okay, so we've managed to write a method that allows us to get a token and store it. The next step for us in our OAuth journey is to be able to make a request to the API itself. So we're going to add another method into our Totara OAuth client just to allow us to make generic requests. So this will be very similar to what we've got here, but instead of getting a token, we're getting some data from the API. So we're going to make a request. So for this, we just need to JSON encode the query and the variables or the params to generate the body for the request. So the body is going to be JSON encoded, and it's just going to be a key value object with the query, which we're just going to pass in, and property called variables, which will contain what I've called params. And then we're going to make a request now, just using that body. So again, we're going to be collecting the response. We're going to be using our client HTTP library to make a request. And again, it's a post request. And then we also need to set some headers on this one. So we're going to set the body as before to the body we've defined above there. But we're also going to set some headers in here because we need to pass our authentication headers. So the library allows you to pass an array of key value headers. So we're going to pass authorization, which is the standard authorization header. We're going to use the bearer token and this get token here to set that. We're going to set a content type. We're going to be passing JSON. So do application JSON, and we'll pass an accept as header as well because we'll be receiving JSON as well. And then we're just going to do what we did before, get the content and extract out what we've got here. And then we need to just do some error handling here as well. So we'll just do that quickly. Okay, so the purpose here is to make sure that we can catch the exception if there's an expired token. So normally you make a request for a token, then you use that token in a API request. But it's possible that you've saved that token as we have, and the token has now expired. And so in that scenario, you want to try twice. You want to kind of have this retry behavior, and we're going to implement that. So we'll just make sure we can capture that there's a different type of exception, um, so that we can catch those and retry. And then we're just going to return the response. This should allow us to make a request. And I think what we'll do is we'll write one more, and this one's just going to have that logic for retry behavior. So we'll make use of our exception here. So we'll try to get a response just by making a request um, with the query and params that we've been passed. And if that doesn't work because it's an invalid access token exception, then we'll get a new token and make the request one more time. Now, if the second one fails, then obviously something's wrong. So we will allow that to fail. And then we're just going to return. Let's just return the response data. So to test this, I'm just going to write a simple method in the sync request function, and we're going to do what we're calling get status. So get status is going to be a very simple query to the API just to find out if the API is up and running. We'll talk about this syntax a little bit more, but I'm just going to, for now, just write this query. And then we should just be able to call that method because we've got our client here. Okay, so that's in sync request, so we should be able to instantiate one of these now. So we've got our source client. Let's actually source. Let's do source requests, and we're going to make ourselves a new sync request object, and we're going to pass in our source client into that. And then here we're going to get rid of these lines, and instead of getting our token like that, we're going to do source requests get status. And hopefully that will run the query, authenticate if it needs to, and return the result. So let's give it a try. And there you go. So here's the response. So we've got the data object, Totara Web API status, and it's just returning a status and a timestamp. So yeah, that's all seems to be working. We've got authenticated requests going to the API, getting tokens, and getting requests. So I think that's a good moment to pause and save our work. And I'm going to tag this with step 2, in case you want to get to this point. Oh, I've already done step 2, step 3. We've successfully managed to generate our first working query. It's a very basic one that just gives us the status of the API, but we've managed to get it authenticating, and we've also got the retry behavior. If the access token expires, then it will retry. So let's move on to something a little bit more complicated and write our first proper query that we're going to use for this syncing task. Um, so you can just write that within your PHP code if you want, but it can be quite helpful to use a GraphQL client to make to put these requests together. The reason being that it allows you to take advantage of some of the GraphQL features, such as auto completion and stuff. So I'm using PHP Storm here. Again, there are lots of different client options. You can use Postman, you can use something like Altair, which is a Google Chrome plugin. But I'm just using the PHP Storm. And I've just set up for PHP Storm, the way you set it up is via a configuration file. So there's a plugin that you can get for GraphQL. You can set up these multiple different endpoints that you want to visit. And in this case, I've just pasted in a couple of auth tokens in for the two sites that I'm going to be connecting to so that they're ready to go. So once you've done that and you've got your GraphQL up and running, you can use introspection, which is where basically it queries the GraphQL API to understand the structure of the API itself. And that then allows the tool, the client, to do auto completion and various other features, sometimes things like documentation, automatic documentation. So I've just got a GraphQL scratch file here. And if I just start typing, you'll see I get auto completion of the syntax. I'm just going to call this test. And then if I start typing here, you'll see it's found a query called Web API status. And I can start, basically using that straight away. And if I do something like, I think it's control space, it'll show me all the options I've got available to me. So let's use the status field. And maybe I want a timestamp, and I know timestamp happens to have a format argument, and we can ask for that as a date time long, for example. And if I run that, I get the result down here with my timestamp. So this is really useful for just quickly getting your queries working, see what the result is, and once you're happy with it, um, you can paste that into your code that's doing something else. So let's write a get users query, and I might just show one other feature here. Let's get this up and running first. So the query I'm going to use is call user users, and let's see what it receives. It receives a query argument, and the query argument accepts pagination and sort. So let's put in pagination. And what's that need? So this is basically the cursor that you want. So this is where in the set of users you want to go. So we'll leave that blank because we just want the first results. Limit is how many you want on a page. So let's say let's just try 5 for now. And then page isn't used. So that gives us our pagination. And then we're going to use sort as well. What options have we got here? It's an object. So column, let's sort by time modified, and direction, let's go for descending. You can see here the comments from the schema are automatically brought through here, so that gives you a bit more context. And there's actually a documentation tool window here, so you can see kind of more comprehensive documentation, I think, on the thing that you're looking at. So yeah, that's quite useful. Move that out of the way. Okay, and then I need to add on the results that I want. So I'm going to get the items, which is a set of users that I'm going to get. So let's get, say, ID number and username. And then I'm going to get the total number of results that there are in the whole query. That'll tell me how many records there are across all pages. And I'll get the next cursor, which will tell me how to get more results. So I'm just going to do this against the integrations endpoint because I think there's more users in there. And let's try running that query, see what we get. So you can see here, here's the results. So I've got the items with their ID and password, ID and username. You can see there's 10 results in total, and this is my next cursor. So I only got 5 results from that. So if I wanted some more, then I need to take that cursor and I add it in here under the pagination. I add in the cursor. And that should give me some more results. Yeah, that's the second page of results. And you'll see there's no next cursor because we've reached the end of the result set. So there was only 10 records and I got 5 each time. So yeah, that's how you can basically build up the query that you want to write. We're just going to go through one more kind of general GraphQL feature before we move on. So I could copy that now if I was happy with that into my code. But one thing you'll notice here is that I'm mixing kind of user input and the syntax of the query together in one kind of string. And if you think about things like SQL injection, it's kind of bad practice to mix that user input with the data itself or the data with the query. In this case, I'm writing it myself. I have control over it, so it's not really a problem. But it's kind of good practice to separate them out. Now, GraphQL offers a method to do this, which is quite helpful. It's very similar to the schema definition itself, and it allows you to essentially define variables. So what you can do then is you can reuse that query with with different parameters and pass those parameters in. So what I'm going to do here is I'm going to, on the outside of this query, is I'm going to add for myself a pagination property, which is going to have a dollar in front of, so it's a variable, and I've got to say what is that, what type of object is it, and it's actually a core pagination input. That's the input type that I'm using here, and then I'm going to have a second one, which is for sorting, so I'm going to go sort, and this is a core sort input. So those two variables are basically part of the outer query, and then I can use those inside. So instead of building my pagination object here, I'm just going to put $pagination, and I'm going to take this away for now. Like that, and then I'm going to put that in this little v thing here, which is variable. So I've basically moved that into this variable here, and I'm going to do the same with the sorting. So that's my sort object, that's my pagination object, and then I can replace this with the sort argument here. Should work. So it's telling me here that I've tried to pass in a core sort input variable, but the sort parameter of this query doesn't want one of them, it wants an array of them. So I actually need to modify this, make this an array of one or more core sort input objects. So that needs to be an array too. So that's one of the nice things about GraphQL is it will tell you when you've got it wrong before you need to send off these requests. Cool. So we're back to where we were before. We've got our query and we've got our input arguments, but they're just a bit more nicely separated. So let's work out what we actually want in this query. So we're going to be doing this query to get users from both the source site and the target site so that we can compare them and work out whether they need to be created, deleted, or updated. So we're going to want a bit more information about the user in here. We probably are going to still want the next cursor because we're going to need to work our way through results. The total is probably helpful. And I think we are likely to want to sort by time modified, but maybe ascending. So we'll start from the earliest and work our way towards the most recently created. By default, our cursor will be empty because we'll be wanting the first result. And how many do you think we could do at a time? Maybe we'll do 50 items, something like that. Shouldn't be a problem. That'll avoid us needing to actually paginate. But we'll implement it anyway, just to show what it's like. So what field should we start with? Well, let's just start with the basic ones. We'll do first name, last name, email address, and maybe ID number. No, we'll leave ID number. Let's also get the suspended status of the item, of the user, to see if they're suspended or not. So I mean that'll do to start with. Obviously you can get more, but we'll start with that. So if that's our query, just check it works. And there you go, we get a bunch of data through. We get the names and everything should be of the right type for what we've requested. Okay, so what I'm going to do is I'm going to copy that query and I'm going to go back to my sync requests file here. We're going to write a new function, which is going to be called getUsers. What we want to do is make a request for these results. So we can just call this client make authenticated request, pass in our query and parameters, and that should give us what we want, basically, our new get users query. So let's go back to our sync, and instead of calling get status, let's call get users, see what we get. So there we go. So you can see we've got 10 results in total. There's no next cursor because they all fit within one page, and here they all are. So that's up and running. Okay, so that does work, but if you're on a real site, you're probably likely to have more than 50 users, and you could increase the max number to get in one request, but then you're going to start to get quite a large request. It might take quite a long time, and so it might make sense to break down those results into pages. But when you're wanting to get the data for something like this, what you actually want to do is get all the data probably in one go, so you can do that comparison. We're going to write another method here that's going to make it a bit easier to get all of the users without having to write that logic every time. So let's have a go at that. So what do we need to do here? Well, first of all, we can do what we did before. We can just make that authenticated request, right? So let's take this data from here, and we'll bring it in here instead. So we can do that initial request, and now we basically need to check to see if what we've got is valid. We have to do some error handling. And then what we want to do is save those results to some variable, and then basically keep making requests with a new cursor every time. So we're taking the cursor out of this response, setting that to be the next cursor, and then repeating that query each time. I think what I might do is actually write a little bit of a wrapper around the API response. So the API response at the moment is okay. We get data from it, but it might be an error object, or it might be data object with the valid data in it. And at the moment, you kind of have to do a bit of work to work out which it is. So I'm just going to write a little wrapper that'll help us by allowing us to easily get the information we want out of a response. Um, we're going to need to know the name of the request for this. So just to explain why, you'll see that when I made this query here, um, this was the actual query that we called. So this is just my kind of name for the particular request that I'm making. But this is the actual service, the query that we're calling. And if you look at the response data, you'll see, oops, um, you'll see that it's actually put inside of an object based on that. So you'll see it's inside a data property, and then it's inside one called, well, that was the Web API status one. This was our other one. It's inside one called core users there inside data. So GraphQL does this because you can actually have multiple queries within one request. So I can actually do this and fetch two separate queries within one request if I want to. So it needs a key to identify the data that you're returning. And in this case, it's the name of the query or mutation that you're calling. So I'm not going to do that, but I need to know the name of this query. So in here, we're going to have a request name. I'm just going to now just have an API response, which is going to be a new API response and pass in that original response property. So that'll just give us something that makes things a little bit easier. And what are we going to do if there's an error? So we can do if API response is error. Maybe we just want to throw an exception. So new invalid. It's not invalid access token anymore. So let's do an invalid request exception. Yeah, so in theory, now we should be able to get our results from um, by calling this down in the down in here. So let's have a go. Return this get paginated results. So query name. We know our query name is core user users. Our items field is called items. We've got our query and we've got our params. And that should give us what we want. So we're still calling get users in our run method. So if we go back to the terminal, oops, if I run that again. Now one thing is our max request items is already so big that this isn't going to really test our functionality. So let's just drop this down temporarily to 2 and just double check that that actually does what we expect. As you can see, I have got 9 results or 10 results still, so I'm still getting all of the results in one go. So that's solved my pagination issue. So this is something that you could use in your code if you needed it. So I'm going to put that back to 50 now, and we're good to go with our get users query. Okay, so what I'm going to do now is just save our progress to date. Let's have a look. Take that with step 4. So the next step is to actually start working on our syncing class. So we're able now to query for users. So why don't we query for some users and see what we've got? So let's go back to here. We're creating our source client. We're able to make requests, and we've done this. So we actually want the results from this. Let's save this now. And we actually want to get the users from the other site as well. So we're going to need another second client here. So now, yeah, it should be that simple. We can now pull our target users from our target request. So that should give us 2 arrays of users that we can compare. And so when we're doing the comparison, what do we actually want to do? Well, what we want to do is from our source site, we want to say, are there any users on the source site that don't exist on the target site? And we want to create those users. So that's the first thing. Secondly, we want to say, are there any users on the source site that do exist on the target site? And then work out whether we want to update those users or not. So we'll need to compare the fields. If they've changed or if they're different, then we will want to update them. If there's no differences in the fields that we're syncing, then we can throw those out. So we won't want to do anything with them. And then the final set is we actually want to start from the target users and say, well, are there any users in the target users who don't exist in the source users, because we want to delete those. So we're going to be calling the delete method on them. So yeah, our goal is to end up with 3 sets of users. So why don't we do something like this? Let's see if we can end up with a list to create, a list to update, and a list to delete. And we'll call a method called compare users. And we're going to pass in our source users and our target users. So if we write this method and we get back 3 arrays, then that should give us what we need to do the work. And what are we going to do here? So the starting thing is we're going to need to loop through our source users. So we'll do that and see what we've got. And we want to know whether it's been found in the target, because that's going to determine whether we're creating it or updating it. So let's just source found in target. We'll assume for now it's not found, and then we'll go looking for it, and we'll update that if we find it. So now we're going to loop through target users. How are we going to decide whether we found it or not? Well, there's a few potential unique identifiers in the users, but let's just use username. It's a commonly used one. We've just got manual authentication on these sites, so the username should be fine, and we know it will be unique on both sites. So let's just do a comparison on that. Now we still need to know whether we are creating the user or whether we are updating them. If we've found the user, then we know we're going to be updating them if they've changed. Well, so for now, let's just start like this. Let's say to update. So if we get to the end of this loop here of target users and we haven't found a match, so if source found in target is false, then we know we're going to need to create them. So we'll just put them in the create array. So that should capture those two. We'll do a better job with the to update in a bit, but for now, let's just see if we can get this working. And so now we just need to think about the delete. Um, so for the delete, we're going to have to work the other direction. We're going to have to start from the target users. So we should be in a position where we can kind of see what happens with these sites now. So let's give it a go. So first we'll go back to our run method and we'll do something with this data. So we should have all 3 of these, and let's just output something. Let's have a look at the sites that I've got set up. So you can see here I've got a site with just a few users, a couple of users that we're going to see to get deleted. This is my local site that's running via ngrok, so I don't mind if this gets modified. And then the other site's a sandbox site that we've got a bunch of different users who are all existing in. So the idea is to sync from this site and make the other site look the same. So let's run that now. And you can see in the users to be deleted are those two users that only existed on my local site, delete me and delete me too. And then in the users to update, there's nobody to update because there's no users in common between these two sites at the moment. And then within the users to create, we've got all those other users, there's 10 or 11 of them that exist on the source site. So that looks like it's doing what we want it to. That said, there is still one issue which we can't really see at the moment because we haven't got any users to update. And the problem here is that the code that does the updating is a little bit naive. All we do in the update code is find out if there are any users that we potentially might want to update, but we don't check to see which of the fields have actually changed. So you could have a situation where a user exists on both sites, but none of the fields that we're updating have actually changed. So let's see if we can do something about that by updating this logic to improve it. Maybe what we could do is write a method to see if 2 users have changed, or to basically bring in the changes. So instead of compare users, let's call it compare user, and we'll give this the source user and the target user, and that'll give us just a set of differences between those 2 users. And I guess if it's not empty, if we do get differences, then we do want to call to update. But if it is empty, if there's no differences between those 2 users, then we can say, well, we found it in the target, so it won't get created, but it won't get updated either. So that means that user will just be left as is. So now all we need to do is write this method to compare two users together. Okay, so that's everything I think we need to compare the two sites, and we should be ready to move on to the next step, which is to start creating GraphQL mutations to actually do the creating, updating, and deleting. So we'll just commit this and move on to the next step. So we managed to get our sync logic working, and the next step is to create the mutations to create, update, and delete the users. But before we go too far into that, I thought it might be useful to show some of the interfaces that we have for the API within the product itself. So going back to the sync task, you'll notice that um, we created our Totara OAuth client, and we had a client ID and secret, and those are the things that are used to generate the tokens. But where do those client ID and secrets come from? Well, the answer is that there's a management interface within Totara for creating clients and giving those clients permissions. So I'm just going to show you it's under development. And actually, before you even get to there, you need to enable it if you haven't already. So I'll just show you that first. So under configure features, you'll see down the bottom here there's an option to enable the API. I've got it forced on just to make it easy for me, but normally you can turn that on or off. So if you don't want the API to be accessible at all, the external API, you can just turn this off. It won't affect the AJAX requests that are used to drive the JavaScript on the site. So this is just the external part of the API, but we've got that on. And then when it's on, we can see under development, we should see this API menu, and you can go to API clients. So this is where you define your clients. So you can just go add client, um, and what you specify here is just a name. So this is something to describe what you're going to use this client for. So I might call this HR sync to remind myself that's what it's for. Client used by standalone HR sync code. So you can put whatever name and description you want in there. The service account is essentially a user that the client will run on behalf of. So if I look in here, I can just pick a user, and you can give them whatever roles and capabilities and access that you want the API to have, and that's what it will get. So it sort of provides a way of doing access control. Um, if your site is running with multi-tenancy on, then we have support for clients at both the system level and also within a tenant. And if you're within a tenant and you're adding a service account, then your user has to be in that tenant, and that will restrict the access to what that tenant client can do to within the tenant as well. So you can use it to work with multi-tenancy. And then you can choose to enable or disable these clients at any time. If you disable, they'll immediately stop working with API requests, but you can enable them later again if you need to. So you can see here I just set this up. It tells me the details about it, and then I've got some options here where I can edit those details again. I can disable it. I can get rid of it if I don't need it anymore. So that's the basics of a client, and then you just take that client ID and secret and use it to request tokens. While I'm here, I'll also show you a couple of other things that the API supports. So the first thing is there are some global settings for the API. You can use these to add restrictions at both the site level and also a client level around rate limiting. This is basically how many requests can come into the API, or the cost and complexity of those requests. You can also restrict the maximum complexity of any one query, so set the maximum that is allowed for an individual query, and also control the depth of the queries. So the depth refers to how many levels down the GraphQL tree you go. So here I've set it to 25. And then the final setting we've got here is the token expiration. So there's a default token expiration here for all clients, set to 1 day, but you can also change it at the client level. So these are the site level settings. And then if you go within the clients, you can see here, client settings. You can override that client rate limit, so you can reduce this if you want a particular client to have less. You can't increase this beyond the site limit, but you can reduce it. You can also change the token expiration, and in this one you can increase if you need to. So you can have a single client that has a long expiration if you're doing development or something, but then other clients will start from the default, and you can change them as required. So those are the main settings that we have right now. The other thing that's of note within the product itself is the API documentation. So this is in the product because it reflects the state of the particular site that you're looking at. So both in terms of Totara versions, as we release new versions, the API will evolve, and so you want a comprehensive reference of the site that you're looking at rather than just knowing what the latest version of Totara has. So you can see the requests that are on the particular site by going to this page. The other thing is that the API is written so that you can extend it as a partner, and so you can write your own API services, and those will also appear in the documentation. There is a build step to generate the documentation, so uh, we'll build as part of the release. So if you're on a released version, you'll get the documentation. But if you make changes to the schema and you want those reflected here, then there's a build step that we can point you to the documentation for. So the documentation, the first section is really just a bit of a quick summary of how to use GraphQL, just built in. Give you some quick examples if you just want to do this directly via curl, how to authenticate, how to request a client, and what the structure of a query is. So just some very basic documentation. We obviously have more documentation on our public development documentation and also our help site. So, but that's the first part. It's just some introduction documents. And then when you get into it, you'll see we've got for different components within Totara that have external API features, you'll see that we've got queries, mutations, and types. So queries represent read requests, mutations are write requests, and then types represent the types of data that you're getting back. So let's have a look for users. You can see right now we just have a core users query, and this is telling you how to get, gives you a paginated list of users. So we've already used this, but you can see this gives you an example query that you can copy and paste, so you don't need to necessarily work out the structure. And it'll also tell you what the variables are like and give you an example response, so you can see what the data might look like if you got some data. This is made up of, as we mentioned before, the query is actually an object itself, and the return type of this data is actually an object as well. So you can click, if you want to see what the query object looks like, you just click on it, and you end up seeing that there's a pagination field and a sort field, and then the pagination field has a cursor limit and page. So you can kind of work your way through to get down the levels of the request. And similarly with the result, you can see the result field returns items, which is an array of users. If you go to core user, you can find out the structure of a core user object, get an example with the data and everything that you need there. So yeah, that's how you might work with the documentation. And you can see something that we're going to use now is that we've got 3 mutations here: create, delete, and update user. So we can use this as a starting point for our code that we're about to write. Types, this is things like the core user object and some of these return types and input types. I'm just going to show you one special type that we have, which is something we're going to use as part of this work, so it's quite useful. We have a type that's we call reference types, and the goal of a reference type is to basically identify a single specific item for some purpose within the API. So an example of this is the update user query. We need to say which user do you want to update in the site that you're updating, and we need some way of identifying that. So we could ask you to provide the unique database identifier, the ID, but you might not always know that. It might be more convenient for you to use their username or maybe their email address. And so the idea with a reference type is that it has a number of properties which can be used to uniquely identify an object, and you can pass in the one or several that are relevant to you. So in this case, for a user, there are 4 different ways you can identify them, and you only need to pass one of these through. So this is an object, all 4 are optional, but you need to pass at least one, or normally just one, because these are unique objects. So you might just choose to pass in the username, and as long as that uniquely identifies one user, then it will be a valid user reference that can be used to identify the user that we're going to be updating. And we use this concept for other links between objects. So, for example, a user might have a job or a job might have a position, and we use reference types to allow you to specify if you want to set the position on a job, for example. Um, yeah, so let's get back to development. But before we do, I'll just make a copy of this because this could be something that we could make use of. So we're doing a mutation uh, to create users. So let's go back to here. And we're going to do this in our requests area. So we've got our paginated results, we've got our status query, we've got our get users query. We're going to make a new one here. But before we do, let's just make sure it works. So I'm going to go back here and paste in our mutation. When we return, when a mutation returns, the return object is a result set which contains the user that was created. So we can just put some normal user fields in here just to make sure that it was created as we expected. Let's just do the for and email actually. So yeah, that'll be enough. And then we need to pass in the input object. So we're going to do this, and we need to know what the structure of that input object is. So we can go back here, and we can see here these are all the fields that are available, and there's actually an example. So let's copy, we'll just copy those fields. Should be enough that we need. And we'll drop them into the input. I just need to make sure the syntax is correct. Yep, my input object, I've got username, email, password, first name and last name. I think those are all the required fields. Just get rid of that. Unfortunately, it does need to match. So if I execute this, I should basically be able to create users on my site. I'm going to do this on my local site. So let's have a go, see if it works. We'll see that I've got 5 users on this site at the moment. But then if I run this query, you'll see I get a user returned with an ID, which looks like it's created it. And if I reload this page, then you'll see it's created that user that we were trying to create via the API. Now there's one more thing I can show you here, which is the site logging. So if you remember, we set up a service account, which we used in the API client. So if I go to the site logs, I just look for today. You can see here we've got, this is the user that we created. We've got the create user event. This is the affected user, the user that was created. But you can see here that this is the name of the service account that was associated with the API client that made this request. And if you want, you can filter to just API requests. And that will show you all the API requests that you've made. And you can also filter by a particular participant. So if you just want to see an individual client and see what requests they've made, you can do that. We probably don't need all of these fields. Let's just get the ID. And now we're going to write a new method here called create user. And that should be all there is to it, to creating a user. So let's work through the other ones that we need. We need an update and we need a delete. So let's go back to here, figure out the structure of our update mutation. So this is the one that needs a user reference. So this is the thing I mentioned before. So we're going to be specifying a target user via a reference, and we're going to be specifying an input with the data that we want to change on that target user, and then we'll get back the user object, the updated user object. So let's copy this. See again, there's an example here of this in use. You can use as a reference. And then let's finish it off with the delete user one. So in this case, we just have a reference because we're just specifying the target user and we're not providing any data to change. We're just saying which one we want to delete. So yeah, we've got our core utility functions. We should get a sensible response from them. We can create, update, and delete users, and our sync code already knows which users we want to create, update, and delete. So yeah, we should be ready to try to do this. So we can go back to our sync task, our run part, and we should now have everything that we need, I think. So if we go back here and run the sync, you'll see it there, removing users that shouldn't exist, updating users, nothing to update, and creating users. And if we go back to our site and reload this page, should see all these users now match what was on the other site. So we've tested create and delete quite well there, but because we didn't have any matching users, we haven't really done an update yet. So let's just do an update. I'm just going to change this record on the target site. And we'll just change Sylvester Cat to Sylvester Dog. So what should happen is the sync should detect that they no longer match, and it should make sure it runs an update. So there's Sylvester Dog. So if I run that sync again, we should find we don't have any users to create or delete anymore because they've all been synced, but we get one user who needs to be updated. And if we go and look at the site, this Sylvester Dog, we should find when we reload that it's been switched back to Sylvester Cat. So it looks like our update code is working as well. So that's, I think, everything that I've got to show. Hopefully that's been useful, and if you do have any questions, then please have a look at the public developer documentation for the new API, and if you're still stuck, you can always open a support ticket. So thank you very much, and see you again soon.